Good evening, folks. It's been a while since I've been able to post up. A lot of crazy stuff going on, but for some reason, I now find myself with an abundance of time, and it's about time to get back to these videos. Of course, one of the things you're going to notice is that I am kind of looking down at you because I'm recording on my phone instead of my laptop. I'm no longer going to be burdening my wife's laptop with recording these, but I am waiting on a high functioning webcam. So I'm not going to be doing the next few videos on my computer, although I'll be editing them there to post up a few things as I need to. But I will be continuing these videos sporadically because I'm doing a lot of other things as well. But I will be trying to get back to these, especially these main points here where we're talking about the pillars of evolution. So in my last video, we did talk about the fossil record as a major pillar, and we discussed in generalities why there were major flaws in the fossil record. And today we're going to deal with some specific quotes and some of the specific examples of fossils that have been found that have been alleged to be missing links or evidence of a change in the actual type of animal over time, from something that, for instance, was not a horse and became a horse, or was not a human and became a human. And then we're going to talk about my favorite fish. So the first thing that I want to address is the idea of the horse. There is a kind of a continuous evolution, a family tree of horse that is presented over time, that we see a lot of examples in our textbooks, not necessarily in this particular textbook that we're examining right now, but it is touted as one of the main pretty or perfect pictures of horse or of an animal. And so we start you'll typically find this. You can easily search for this online, and you can find where they make these claims based on a couple of major factors. Number one is the feet, and number two is the teeth, the way that the teeth are formed, and whatever. And so they start with something from the early Eocene. And remember, they just made up these timelines. We haven't got to radiometric dating yet and the geological timeline. So when I name these time periods, these are the ones that the evolutionists use, not the ones that I hold to or believe in. So the first one that we generally see is from the early Eocene era, which was about 50 million years ago, and it's the Hyracotherium, and it was a five-toed animal that ate. And remember, all we have is bone structure fossilized. The bones themselves have turned into rock, and so we only see the structures of the bones as we find them as rock. We do not have the flesh, the soft tissue that surrounded the bones, and so there's a lot of things that we kind of guess on because of that, and I'll deal with that in my last example. But the Hyracotherium was a five-toed creature, and based on a very small tooth, kind of a wide flat tooth, it was kind of a browser. It would eat leaves, and it would eat berries, and it would eat just kind of whatever vegetation it could find. But it was very small, almost rodent-like. And then at best, it's 0.4 meters high. We're talking about like a large rodent or a small dog. You're looking at 0.4 meters is 40 centimeters. 40 centimeters is you're looking at somewhere around an adult's knee at that height. And then you have Mesohippus, and then you have Merychippus, and then you have is it Pliohippus? Yeah, sorry, my screen's a little messed up here. And then you have Equus, which is the modern horse. And in each of these, you see this so-called transition from the number of toes going from 5 to 3 to 1, and then you see the tooth getting longer, and they go from more of a browser to a grazer where they're eating grass, and the diet has slightly changed. They're still vegetarian, but their diet has slightly changed, and so that's how it's presented to us. I'm looking right now. I really quickly pulled up a Wikipedia article on the horse evolution. You can find it in textbooks. You can go to the Talk Origins website. Any number of sources will give you the same exact line of unbroken horses, and the problem that is faced with those is they claim that these are transition fossils all the way from what I'm just going to call Hyra all the way up to Equus. And when they make those claims, what we're supposed to believe is that starting with the Hyra all the way up to the Equus is that there was these gradual transitions between each of these types in the fossil record, and there's not. And what we find is where a particular skeleton in the fossil record, according to them, the smallest of them, existed, and then there's an abrupt change with a major shift where there's no fossils indicating an in-between phase, and it's a major change to a completely different kind of animal that's supposed to be far more advanced, far more complex, and then that version lives for millions of years without any kind of change whatsoever, and then suddenly there's another jump, and what we see, just to read from a 20th century evolutionist here, Stephen Gould, said there's no evidence of long-term changes within these well-defined species through time. Instead, they are strikingly static through millions of years. Such stasis is apparent in most neogene horses as well, and in Hyracotherium, this is contrary to the widely held myth about horse species as gradualistically varying parts of a continuum with no real distinctions between species. Throughout the history of horses, the species are well marked and static over millions of years. At high resolution, the gradualistic picture of horse evolution becomes a complex bush of overlapping, closely related species. And so what they're saying is that these things don't appear to be one after the other in terms of genetic relationship or heritage. Is you just have a clump of animals that are all the same and they stay the same, and then they die out. And so it's not a tree, it's just a bunch of neighboring bushes where these animals overlap based on their fossil records and what strata they're found in. And so the way that it's presented here, one cannot speak of an evolutionary family tree for the horse. A clump of neighboring bushes would be a more appropriate analogy. Stephen J. Gould called this a lateral stepping interspersed with long periods of stasis. So the horse, while it is presented to high school students as a viable example of these gradual transitions from one to the other, is anything but. It's not. It's static animal, and then boom, new animal that is significantly different with nothing in between. They in some cases coexist for a moment in the geological history, and then the smaller one dies out. And I don't want to say the earlier one because they're making assumptions about those layers, but the smaller one dies out, and then the larger one is capable of surviving for geological millions of years, and then it dies out. And then there is another one of a larger, allegedly more advanced creature, and then it dies out, and then suddenly there's horses, and they try to call these missing links, or they try to call these gradual things, and they're not gradual at all. They're completely different animals. Where you go back to something like a dog or a large rat, or some kind of an animal that's a vegetarian type animal that died off, and then you suddenly have a horse, and they have some similarities, just like a horse and a dog have some similarities, but they aren't the same animal, and it's just not the example that they want us to believe it is. It's not the example that they foster it off to be. The next one that I want to talk about, the next specific example, is the Neanderthal. The Neanderthal, and this is going to be a series of human things here, but we're going to start with the Neanderthals. The Neanderthal was thought to be the earliest human ancestor to like the modern Homo sapien, and they said that it died out a few million years before humans. Kind of overlapped a little bit, looked a whole lot like us, and would have been a true gradual change. And then what they did is they came out when DNA became a thing. And when we could look at DNA, they extracted some mitochondrial DNA from the Neanderthals, the original Neanderthal fossils that we found. And the fact that they could do that was problematic in my mind, because DNA and genetic material just doesn't last very long. But they were able to extract some mitochondrial DNA, and they made the claim that, if you look at, they compared 1,669 modern humans, and they took an average. So it was a statistical thing that they did. They took an average and they compared it with a Neanderthal mitochondrial DNA, and they said, look how different the Neanderthal is genetically from this statistical average of human DNA. And the what they wanted to do is they wanted to say that, because there's so much difference, Neanderthal isn't actually an ancestor of humans. They were a branch off from a common ancestor with humans, but that branch didn't go anywhere. They all died off, whereas Homo sapien continued on, because they couldn't find the little flags inside of the DNA that they needed to say that it was an actual ancestor. And so that became a problem. And then they eventually made some adjustments and came to understand that there's some statistical finagling here. And so it goes back and forth. Do we put Neanderthal as an ancestor of humans or not? Well, the problem that you find with this is that, number one, it is a statistical issue. If you look at modern humans, the substitution differences just from a large number of humans is so big that there are a number of groups of modern humans that you would have to classify as a different branch of the so-called evolutionary tree, because the DNA is different enough that by their standards, they're not human. Well, man, that gets back into eugenics. That gets back into all the things from the early to mid 20th century with the Aryan race and all of that, and that is not a path that we want to go down. It's humans are humans. It's very obvious what are humans, and for them to sit here and do some number crunching and just this little statistical manipulation that they do is kind of a scary thing, because it's going to start declaring that there are people who appear to be human that aren't Homo sapiens, that aren't humans, and then that goes where that goes. So that's one problem. The other problem with the Neanderthals is that we have found multiple cases where Neanderthal skeletons have been buried with Homo sapien skeletons, and that it indicates that they were parts of their families, that they were included in everything of that life, and that they were contemporary with humans. They were not something that came before humans. and that there isn't really any enough deviation, any more than there would be, the deviation between like myself and maybe somebody from Australia, or myself from East Asia or something like that. There isn't enough differentiation to say that Neanderthal was anything other than a human being, and so it's not a missing link. And I'm going to head up on some of these others just to kind of give you an idea of where these things. Let's see if we can get this thing to go. Nope, I just want to go there. All right, so the next one in our so-called missing link is Nebraska Man. And it was heralded as the first higher primate of North America by Henry Fairfield Osborne in 1922 on the basis of a tooth found by Harold Cook in Nebraska in 1917. It was classified originally as Hesperopithecus Cooki, after Harold Cook. And it actually ended up being it's not a hoax, but it was a mistake. And so they had to withdraw Nebraska Man from that. So it was a misidentification, and it was retracted in 1927. The next one is Piltdown Man. And so Piltdown Man was some bone fragments, and that's one of the major problems that we find with these, is that we really just deal with bits and pieces of a skeleton a lot of the times. And because they're just little bitty bits and pieces, they can put the rest of it together in their imagination however they want. So they had a jawbone, some skull fragments, a set of teeth, and a few primitive tools. And they finally falsified this, or showed that it was a hoax, in 1953. And they said in 1912, Charles Dawson claimed that he had discovered the missing link between ape and man. And so he reported his find, and it took a long time for them to, it's 1912 to 1953. It was finally exposed as a forgery, that this guy had put these things there, that he had wanted people to believe in evolution. And so it ended up being a mandible, the jawbone, that he had physically altered himself. He had grabbed some teeth from an orangutan, and then he had found some skull bits of kind of a smaller human, but just a regular modern human. So you have that one is an absolute hoax. And then I'm just going to go through a couple of these others just real quick so I can get on to my favorite, the coelacanth. The next one is the Ochre Man. This was touted as a missing link for a while, but it's a single skull cap. It's the kind of the top bone of the head, and they said that this was a missing link between man and ape, and or our ape-like ancestors. And it turned out to be the skull cap of a donkey once they got down to it. So that was fake. Java Man was a tooth, a thigh bone, and a skull cap. Those were the three things that they found. Turns out that the tooth and the leg bone were later determined just to be human, and the skull cap was of a monkey from a different body. So Java Man was not a missing link at all. And so we've covered 5 here that are touted, and they're still touted. A lot of them touted today in textbooks, because textbooks take so long to kind of turn over. And so we still see them in textbooks used today as missing links, and they're not. They're either a fraud or they were a mistake, as they call them. They're the so-called missing links are very few and far between once you start getting to examining them. And then the most famous of these, of course, is Lucy. And here they found Lucy, and I still have the magazine article from Time that talks about how Lucy was not what we had originally intended. That's not how the article is framed, but if you look at it, what ended up happening is they found a relatively complete skeleton. It looked like a very small human being, because that's the thing, is that as evolution happens, things get bigger and better and more advanced, and so Lucy was relatively small. And then they had found a single finger bone nearby. Well, when they say nearby, that was actually 10 miles away is where they got that from, and they put it in with the skeleton, shifted off to the museum, and it was put together by a person who was not a biologist. There's somebody that was not a scientist at all, and just wanted to put it together to make it look like a nice display. And so when people came in, they assumed that a scientist had put it together, and so they got to examining it, and they said, "Oh, this is a female of an early pre Homo sapien," and they examined these things and they made these assumptions or whatever. Well, it turns out that later on they figured out that it wasn't put together right. Turned out to be a dude and not a female at all. And once they put it together, and they had all the parts in the right spot, and they kind of ignored the finger bone that they found 10 miles away, turned out to be just a monkey. And so Lucy, the most famous of all of the so-called missing links, isn't a missing link at all. It's just a young male monkey. And so, and we could keep examining these. We could go down to every one of these missing links, and you're going to find that there is more assumption and outright desperation than anything, because there are so few of these fossils, where Darwin predicted there would be thousands upon thousands of them. We just don't have them. We just don't find them. So the last one that we're going to talk about today is my favorite fish, and that's the coelacanth. And for a long time, you had the evolutionists would talk about this fossil, this coelacanth, as the missing link between the sea and the land. And what it was is this shallow water fish had a skeletal structure that suggested, remember, they're not about knowledge, they're about just reasonable confidence here, which they want to be confident in their hypothesis. But this shallow water fish had skeletal structures that suggested that it had proto feet and proto lungs. And what you'll see in all of the textbooks is that the coelacanth lived near the beach. It was in the shallow waters of the ocean, near where it could crawl up out whenever there was a predator around. It could crawl up onto the sand, and it could survive with those pseudo legs and those proto lungs for a little time out of the water, until the predator either got its fill from other creatures or got bored and went away. And so that's the coelacanth. Well, in 1928, they were fishing off the coast of Madagascar, and they pulled up this really ugly fish that they didn't know what it was. They didn't have a name for it. It had a local name, but they had it was just this really, really ugly looking fish. And the problem is they were deep sea fishing. So we're not near the beach at all. We're not in the shallow waters, but they are deep sea fishing. And so they pull up this creature that's a bottom feeder. It's kind of like a catfish of the sea. And when they started examining it, the guys that were there, the locals, were like, "Oh yeah, that tastes horrible. We usually cut it up for chum and just throw it back in the water." And so there was a guy that was out there fishing with them that was curious about it, and he wanted to cut it open and see what it was like. He was a scientist, and he'd never seen it before, so he would, I want to see the skeleton. Well, it turned out to be the skeleton of the coelacanth, unchanged after like 400 million years of alleged evolution. And it was a huge shock. They call it a living fossil because somehow this fish had survived 400 million years unchanged. But the problem is all of the assumptions that they had made when they only had the skeleton were all wrong. It did not have proto legs. It just had fins. It had no lungs, no proto lungs, nothing of the sort. The extra skeletal structure was because it was under so much pressure, being under all that water, and none of the soft tissue matched the predictions that they had about what this creature should have been like. And so it completely blew out of the water all of the assumptions and assertions that they had made about this fish. And so that's why coelacanth is my favorite fish. It's absolutely devastating because it shows this surprise. Hey, here I am. I'm not dead yet. Kind of a Monty Python moment here with the coelacanth, is that it shows that when they make these calls, when they try to assert these truths based only on the skeletons, they don't have enough information to make these calls at all. And so generally what I like to do is when somebody wants to talk about fossils and they want to talk about how evolution is true based on the fossil record, I'm going to say, all right, well, let's talk about the coelacanth. And it's kind of an end. It's a non-starter for them because the coelacanth just does not have the structures that they wanted it to have. They got it so wrong, and they can't go anywhere from that. So anyway, that's all I got for today. And so I'm gonna head up a few other topics as we go along. I'm still going off 298 in the textbook, still hitting each of these small things really slowly, and we're going to try to hit these pillars. But the fossil record is a pillar that we just have knocked out. It does not fit. Certainly happy to answer any. If you have some suggestions or a specific example you want to talk about, I'm happy to do that. Leave that in the comments. But I'm going to go slow, and we're going to hit each of these as we come to them. So thank you for tuning in. If you like this, click the up thumb button, subscribe, share, whatever you need to do. And I look forward to your comments. Y'all have a good one.